My name is Peter Johansson. I'm one of the co-founders of Baltic Yachts. Better like this. Okay. We started our company in 1973. We were 5 of us, and all 5 worked at that time at Daughter, so on. And the rumors around, of course, after we started our company, the rumor was after we started our company that we were disappointed with working with Vaughan. We wanted to do different boats, and we were not listened to at the company. This is totally wrong. We were all very proud of working at Vaughan. We were happy with that, but we wanted to try our own wings and see how far they would carry us, which I think is the case for many people. And now it's 40 years, and we have a turnover today of about 30 million plus. The number of people is between 180 to 200 people employed. We started with 0 production yachts, which we did in the beginning, plus some custom yachts, and we went up more and more over to big, large custom yachts. And today we also do what we call life cycle service. We get some of the older boats back and do repair and service. And up till now we've been building close to 600 boats in total. These are standard models in sizes from 33 to 66 feet. And we've done individual yachts, custom yachts in sizes from 38, which is the smallest one, up till 197, which is the biggest one so far. But we can do even bigger if we get the opportunity from a client. The idea from the beginning of the company was to use modern technology in order to build the boat lighter, and in that way improve sailing performance. We get high stability, high speed, but also the modern materials like epoxy will make the boats more durable. And of course, quality is always an issue when you build yachts. One thing that we also had in our philosophy from the beginning was that we would be very flexible. On the 0 production boat, we would give the clients more options to do, and we would work more individual with each client. But we also from the beginning had the idea that we would do custom, totally 100% that we would develop with the clients. The advantage of building a lighter boat was that we would get more symmetrical lines under here. We would need less sail area, less loads, and easier we would get a higher performance. But lighter construction always means that you need to use more high-tech materials. And the idea was to use high technology methods and materials to achieve this. But also you have to have very detailed weight calculation, and you have to know what you're doing. Have a good weight follow during the process. And all this would be done. The idea we had was to do all these projects in very close cooperation with Naval Architect, and what we call a total concept. I mean, in the beginning, I remember when we had made our boats and we had lighter specification, lighter displacement, and many others, that we had some competition saying this is not possible because they use unidirectional fibers and they use sandwich construction. But even if we would take away our complete laminate, we wouldn't achieve the weight that Baltic is achieving, so they cannot be right. But this is what I mean with the total concept is the following. When you do this decision, when the boat is still in the designing stage, you do it together with the naval architect to have ratios like ballast, displacement ratios, sail area, displacement ratios. Now, if for some reason you make a decision and you can make all the changes that, okay, let's do a laminate where you say 1,000 kilos, just to take an example. Well, if you're going to maintain the ballast percentage, you get a 400 kilos lighter ballast also. And now you look at your sail area. You have too much sail area for the displacement, so you can reduce the sail area, you reduce the rigging load, you reduce the weight. Okay, now your keel is too heavy again, if you want to stay with the same ratio. So in other words, we call it the mathematical circle of yacht design. And it doesn't mean that the boat disappears if you do them enough times. It means that if you do it properly, your weight saving is quite a bit more than your original 1,000 kilos. So this was the thinking behind all this. But this means that you need know-how within the boat builders company, and you need to work closely together with naval architects. This is the first boat that we did. It's being tank tested, so we were pretty scientific from the beginning. I just go fast through some of the milestones of our company. This is the first building we had. It doesn't look very nice, as you see. We made 4 of these hangar buildings, and they're probably the best investments we've done because they gave a lot of return on the money, I can tell you. But they were not very nice to look at. And I remember when we had our official start of the company, we invited a minister of commerce and whatever in Finland. And I really wondered after that opening what he was thinking about it, because it was a little bit nicer than this, but not very much. Anyhow, I think later on he found that he actually was involved in starting a fairly good company. This was the first boat that we did, a 46-footer that was delivered in 1974, showed at boat shows in Hamburg and Paris, and very well received. This is actually the first custom, total 100% custom boat that we did. It's a flat-out racing machine, a 2-tonner, and that was already in 1975, so 2 years after our start. This is I can only show you a few of the models we have done through the years because we don't have time to go through the whole thing. This is a 42 CNC design that we did in 1976. This is one of the more successful models we had at Baltic 39. Also CNC design done in 1977. Another flat-out racing machine, 2-tonner, Douglas Peterson design in 79. And this is one of the really nice models that we came out with 75, it's a CNC Baltic 51. Very, very nice and successful boat that we had. We sold it quite a number. One of the things in the 75 was that we had our own in-house designer, Thor Hinders, and he came up with the idea that, hey, it's a 2-cockpit boat. Let's make in the owner's cabin aft, a double berth under the aft cockpit. So we came up with that idea, and he did this layout. And of course, a lot of people said, oh, that's not sailing, that's just a motorboat thing, and you can't have a double berth in a sailing boat and so forth. And they said so until they found out that we had 3 wheelboards in this bed, one in the middle and one to each side, and beautiful beds for sale. And then everybody started to copy this. So this is one of the more copied things, I think, in the sailing business today. But it came actually from our Thor Hinders. In 1980, we were purchased by a Finnish shipyard, Holmen, and then we got a little bit nicer buildings. They should like that for us. That part of it. This is the yard in Boson where we originally started. You can see the hangar buildings, but then in 1980 we got this new big building. 1982, we did one of the first, those days they were called maxi racers, 80-foot racers, IUR racers out in the world, and we did one of the first in fiber technology. Maybe not the first, but it was definitely one of the first. This was for a Scandinavian client. It did have some interior, it had an owner's cabin and a lab station and a galley, but for the rest it was empty. Beginning of the 80s, we started with a serial production model, which was a Baltic 43, but halfway through that project, standard the boat was very, very high-tech. It has sandwich construction, unidirectional fibers and all that kind of thing. So, but in the middle of that project, we also started to use epoxy, vacuum laminating epoxy, and also to some extent carbon fibers in construction. We actually worked together with a company in the United States, which was called Monitor Aerospace, which was very big in titanium parts for the aircraft industry. And the owner of that wanted to do some parts for us because he said they're in the aircraft industry, but it's made in titanium today, will be made in carbon fiber in a few years, and I like to learn. So we got some of the most beautiful rudders in the yachting business you can ever think of, because they spent the aircraft money on it. 1987, we did a large Parkman Stevens designed 83-footer where we did our in-house designers did the styling of the deck and the interior, but Parkman Stevens did the naval architecture. This is the main saloon of that particular call, and that's the house cabin. Then I want to touch a little bit about technology, because technology has been a big part of Baltic's success. And we used in the beginning, before the beginning, we used unidirectional fibers, sandwich construction. We went fairly early into epoxy, vacuum consolidated laminates and vacuum infused laminates, and last year we've done almost 100% what we call pre-preg carbon laminates. I'll show you a little bit of that later on. Simplified, what was very common in the, or is still common in the fiberglass joint building business, is to use woven drawing, which is the top picture here. And in a woven drawing system, all the fibers are bent. And you have a lot of resin concentration between the fibers. The resin concentration has a tendency to shrink, so you see that on the surface. And also when you look at it from an engineering point of view, since the fibers in a laminate are the structural parts, it's silly to have them bent. It would be like if you build a concrete bridge, you would have the iron bended all around in the concrete. Well, that bridge could hardly carry its own weight. So on concrete construction, you put even pre-tension on the steel in order to carry the load. So it would make a lot more sense that the fiber were as straight as possible. Disadvantage with straight fibers in unidirectional like we do this is that you don't build up thickness, so your panel stiffness will be too low. And then you have to go to sandwich construction to increase the panel stiffness, but the weight saving and the strength is there to do that. This shows a picture from inside an open of what is most our way of building the boats today. This is a carbon fiber construction with a pre-preg laminate. That means that the carbon fibers are impregnated in the right proportion of epoxy in a machine. And the curing process is already started at the factory where this is done. And then they cool it down to minus 18 degrees centigrade to stop the curing process. And it's delivered, cooled down to minus 18 to our yard. We store it in minus 18. And when we take it out to room temperature, we have a few weeks time to apply it on a mold and to put a vacuum back on, put the vacuum on, and then inside this oven, which has to be very well insulated, we have about 16 to 18 large electrical heaters. And we heat the thing up to plus 85 degrees under vacuum. This is one of the curing temperatures for one of the laminates for 152 footer. So you see that the temperature is right up to about 60 degrees. We slow it down there and let it to even itself out, and then we take it up to 85 and keep it there for 10, 12 hours and then cooling down. So this is today's technology, which is as high technology as you can use today in fiber technology. And almost all our boats are done like this today. Maybe not carbon, it could be glass or Kevlar combination, but it's pre-pressed. We do also occasionally do vacuum infusion. I'll show you that later. One thing that we have at our yard is we have a hydraulic press to do flat panels like bulkheads and things like that. It's a hydraulic press with a heated upper and lower table. This is the table where we prepare the laminates and then it's moved into the press. And the heat there is controlled by a computer, so it has the same curve as I just showed you. What this allows us to do is to do very light and strong flat panels and bulkheads. And this is one of the bulkheads that has been done. It's already done with openings and capping around the openings. It's done with reinforcements in the corners. But because this comes out very flat due to the pressure, we have to mark the reinforcements on the bulkhead so nobody will by mistake drill a hole or cut the reinforcement. This makes extremely strong objects and light. This is a sample of a light interior where we use Nomex sandwich as a sandwich material, very thin carbon laminates, thin veneer. And then on edges where you want to apply fittings and things, you have a foam insert. This is extremely light, extremely strong. And this is things that we do. This is another example of a laminate, which is what we call vacuum infusion. That means they put your dry fibers in a mold, and you put your vacuum bag on, and you pull in the resin by vacuum. We do that still on some boats, but it's today a fairly common method. This is a Baltic 67 at Bruce Farr design that we did in the middle of the 90s. This was the first pre-impregnated full carbon project that we did. And it was a full interior boat, but for comfortable cruising, but super light due to the technology. According to our material supplier, this was the largest pre-preg carbon laminate in the world at that time. This was one of the boats that followed immediately after, also extremely high tech, with Nomex sandwich in the hull and deck. And a lot of the metal parts you see on this boat is titanium, just to make the boat as light as possible without sacrificing strength. But still, a very nice cruising boat with a full interior. It's not like it was a flat-out racing machine. We've done those also, but this is not one of them. This is a little bit different. With the custom, most of our production have been zero production boats, and there you have to make something that fits pretty well everybody, and you do make some modifications to fit individual clients. But on the custom side, we can do everything from super modern to classic design. This is the first classic we did. It's a 70-foot Bill Dixon design, and this boat was developed together with Bill Dixon and the client. A lot of decorations, both exterior and interior. Everything designed into the smallest detail together with the client. On a boat like this boat, you do it. This was also a high-tech boat. It was an epoxy hull and very high-tech technology. But when you do this, you can go either super light, or you can say, like this client did, I like to put a part of the weight that you save back into the keel because I like to have a boat that is stiffer than others. So he decided, and those are things that you can do when you work together with a client on an individual basis, and you work together with a designer. So in this particular case, it was like that. The Baltic 97. 1999 build was also a cruising boat, very high-tech, but built only for cruising. A nice boat designed by Udo Frolic and with our in-house designers on interior. This boat sailed around the world a lot. He even took it to, if I remember correctly, to New Zealand for the America's Cup. The interior, as I said, was our own people did styling and layouts. And this is an owner that has come back to us for many, many boats after this. I think we're on boat number 7 now. Then another magic thing that we ended up in 1975, 78 is a canting keel. Then it was popular, if you could cant your keel to the side 45 degrees, you would gain a lot of stability. So we were approached by a client asking us whether we could do this. And I promised him when we would look at it that this is one of the side views of the preliminary design we did. We had a center wall in the middle that would compensate for the loss of lateral area when you would keep the keel. But this was also a boat that was extremely fast, but used mostly for cruising. Full interior, very comfortable interior, but built with super high technology and very, very light. And it's still sailing today, no problem. One of the things with this particular boat, this is the interior from the boat, and you wouldn't believe that it's a canting keel boat, because in those days, the boats that were done canting keel, you put a big, huge mechanism inside the boat, and there's no way you can build interior around that. It was just impossible. One of the demands this client had when I met with him the first time was that I want full interior in the boat and I want the canting mechanism under the floor. Should not be visible inside the boat. And when I came home from the first meeting and I put the data in the computer, I told myself this is impossible. The loads were really high. But then we noticed that we had a little bit too much weight in the valve and we could gain a few centimeters here and there. In the final end, then we fiddled around with the numbers, it was possible. And we built it. I want to tell you also a little bit about what, in order to do the things we know we do, we need it within the company to have a fairly high technical knowledge in computer programming things. So I go fast through some of the in-house software we have. We have a price and weight calculation that we fairly fast and can give an indication of price and weights. We have a comprehensive master rigging software which we've done ourselves. Laminating design, one which we purchased from the outside, another one which we've done ourselves. Keel and floor and bolt designs, calculation for that, also a very comprehensive propeller calculation. Rudder loads and steering balance and so forth. Then we have a purchase program from NaxSurf where we can do preliminary line drawings for hulls and for keels and rudders. And which we can also do hydrostatic calculations so we know exactly how the boats are floating and stability. We have a thruster calculation software, a stability index software, and we have also a velocity prediction program where we can calculate the speed of the boats. And then of course the normal design software like AutoCAD, Rhino and IronCAD plus a few others. This is just a printout of the price and weight calculation. We made statistics through the year where we have a certain lengths of a hull, beams, heights, and we make what we call a size factor out of that. And based on that size factor, we make curves for weights for various size factors based on statistics, and also same thing for the price. And we have 4 different levels of technology. So in a very short time when we're approached by a client, we can tell roughly what the weight would be of the boat and what the price would be of the boat. Then of course, if you get further with the client, you have to do extreme detailed weight calculation. Just a part of one of the spreadsheets that we have for interior, where every detail in the interior, we know the weight, we know the longitudinal position, we know the height position and the torsion position. And in the final end, when I have all this together for the hull and deck and interior and deck fittings and plumbing and rigging and engine and so forth, we get a summary of what the weight is. And we keep, through a process of building a light boat, you put the boat on the scale when the boat is roughly 25% finished, and you measure the weight of the boat then. When the boat is half finished, you measure the weight. When it's 3/4 finished. But we keep track of what we have had on the scale, and then we update also the theoretical, because if you don't update the theoretical, you will lose the vertical center of gravity. Another thing, this is simple mathematics. I think every good yard has this today, it's not that. But what we also done a little bit different is that we have connected this together with a flotation, with a hydrostatic program. So every time when the project manager or the client comes along and to have that and that item in, or I like to move my batteries so and so many meters forward because I like to have something else where the batteries are. So you do change it like that, you immediately see what it has for an effect to the flotation of the boat. So it's a very good tool for the people doing the boat to keep track of the weights. This is a part of the mast and rigging calculation that we do, which is very, very detailed. We were mast builders at one stage, so we had this thing. We also had a cooperation together with the University of Oulu and an engineer that studied there at the time. That was 79, I think, where we had the opportunity to sail with the university computer on board and have a lot of load sensors all over the mast and the rigging. And based on that, we made a software and a program and a presentation. That was, if I remember, presented at the symposium in London in the beginning of the 80s. Now this had changed a lot since then, but today we can, with the input of a board, we can really fairly quick get all the loads. This is loads on the running rigging, you can load on the standing rigging. And the thing here is we also get the weight of the items. This program is connected together with a library that has, for instance, on standing rigging, you take rod rigging. It has a library of rod rigging, what sizes and what are the working loads those rod riggings can take, and what are the weight of the rod rigging. It also has corresponding end fittings and stern buckles and everything. And this program picks automatically from those libraries, very labelers, that information. And in a very short time, we can find out what the weight of a mast and rigging would be for preliminary weight calculation, because sometimes we don't get these numbers from mast builders. And it also takes into consideration hydraulic things like backstay adjusters and what sizes of backstay adjusters you want. If you have a hydraulic roller furling, it would also pick the right sizes and weights for that. And then finally, you have the total weight of the mast with rod rigging or with PBO, and you would have the vertical center of gravity of the same, and longitudinal center of gravity to the boat's 0 point. So this is, normally when you ask to do something like this, it would take you days to calculate. But because this is connected together with libraries, with information, we can do this calculation in about 1 hour. But it took more than 1 hour to make the problem. Actually, it took a whole summer holiday, but that's enough. This is the summary of the mast building, which goes with the boat. And you have the main dimensions and the panel loads for various panels on the mast. You have the loads on the standing rigging, on the headstay, and what numbers you would have, what size they would be, and you have the running rigging loads. You would have what hydraulic cylinders you use for backstay and bang, and what pressure you would require in order to get the load the program there. The same thing for the pearl cylinders. And even what we call the mast job tuning. If you have a hydraulic mast jet, you have a way of setting up that, and this would give the hydraulic pressure on the mast jet also, which is good for the owner of the boat to have. And this is mainly on the bigger boat. And this is a summary of the models. Weight. And then we have another thing, which is actually a propeller calculation program we developed ourselves. This, I won't go through in detail for that, but this gives us the possibility, of course, to operate propeller for a boat, but also to calculate what engine do you really need to get the performance the client is looking for. And then another good thing which it does, the speed and what it does is that it gives us, for a given tank volume, it gives you the range. These are the speeds, and this is the range. For instance, for 8 knots of speed, you would do 2,400 miles. So if you build a boat light and your resistance is lower, you can also, with these kind of programs as a support, can always say, I want to do a full tank, I want to do 2,000 miles, but I want at a certain speed. Then this program would tell us exactly how much fuel does it need to do that. So it's a good tool to have. Another thing that we have also in-house, and we use VPP, we calculate the performance of the boats. This is a complex polar diagram. We can get them in polar, we can get them in number, we can do them in anything. This is complex because it's for a 78, which is a canting keyboard, so there's a lot of curves because it's with different canting angles. But these are things that we also can support and give clients the information they require. Then we have a huge number of statistics where we take main dimensions of the boat, ballast weights, and all kinds of center weights, fair body, LCB keel, LCB total, stability calculations. We got wetted surface areas, we got keel areas, rudder areas, we got sail dimension. And then in the final end, we got ratios like sail area displacement ratios, length displacement ratios, all kind of things that we then put into diagrams, which makes it easy to see what your boat would be like with certain ratio. This is just one of the summary of some of the information we have collected through the year with all the boats we've done. Just to give you an idea. Of course, you can't read anything, but that you can see it. The performance chart that we want to look at is one like this, which comes out from this statistic. On the horizontal plane, we have length displacement ratio. The vertical, we have sail area length ratio. And diagonally, we have sail area displacement ratio. So these lines are sail area displacement lines. Now, if you're up in this corner, you're probably a very good lightning boat. If you're down there, you have a surfing or planing performance. If you're there, you have everything. You have the lot power. If you're down there, you're not in such a good. Now, that's not correct because even good boats wouldn't fit this chart here. They would be outside the chart. So this is a fairly concentrated. But when we're talking to preliminary clients, then this is a good tool to show them where their boat would end up being. And of course, this is just an example of some of the engineering programs that we have, do layouts and equipment here. So why do a yard need to have all this software? I mean, this is software that some of the naval architects hardly have. And we're not naval architects, we have no intention of becoming naval architects, but we think that a good yard should know these things. You want to build a good boat together with a good designer and a good client, you need to know. You need to be able to do this. And we are also approached in very many different ways by clients. We can, sometimes the client comes along with a full package of information. It's drawings, it's specifications, it's every detail. And the only thing we need to do is to put a price tag. But the other alternative is actually this boat that I'm showing you, the 147 program, which is probably yet today the most high-tech 147 built in the world. This client called me at one of the boat shows in Europe, and we had done 3 boats for him before. And he said, I have a vision to build a 140-foot boat. They need to build full interior, really comfortable cruising, but be light enough that it planes, not serve the planes. And is this possible? We said, well, we can take a look at it. We think it's possible, but you have to be really, really tight on the way they calculate. So we did in-house preliminary line drawings. We did 6 different boats with a little bit different beams, a little bit different displacement, sailor, and so forth. And we studied this project for 2 years. And I don't know how many times I visited his office. And then said, okay, this is good, let's do it. Then we contacted the naval architect, 3 of them. And we gave them the possibility to come up with ideas. And then he picked one of those. And in this case was Reicherview. This is the hull being built for that boat. Inside an oven with this 85% curing and very high-tech boat. This is the boat halfway finished. This is just a detail of the chain plate, which was also in carbon. Oh, sorry. These chain plates are a part of the hull and in carbon, and they are designed to take 75 tons of load. Or the actual load is 75 tons, but they're designed for 230 tons of load. So you could actually pick the boat up in these things and easily move it around. This is inside the boat where the keel trunk is being installed. The possibility. This is the boat where we started to do the painting and fairing and priming. This is keel installation with the keel down, and this is the boat being launched. And this boat has been sailing all around the world, and it's been doing well in races, and that's a very happy client. If we look at things like this is all carbon. The white painted carbon. This is carbon, all of it. When you look at the thing, like the metal part, scoop it and push it and cleats and so forth, looks like stainless steel polish. It's not. It's titanium polished to look like stainless steel. And just to polish titanium costs a lot of money. Because it's a difficult material. The interior of this boat is very comfortable. All wood. Looks very, very nice. Have all the facilities you need and nice cruises. nothing, missing nothing. And you look at this thing, you look at it, it looks like a solid wooden post. It's not, it's a thin carbon tube with a thin veneer top. You look at the steps here, it looks like solid wood. It's not, it's a Nomex carbon sandwich with a thin veneer. It's a fraction of the weight, and it's twice as strong as if it would be solid. But this was done for this boat to a great extent, but we had a very good owner here. He's very knowledgeable, and he knows that if you save weight, in order to reach the weight number we had, he had to really save weight. And he was willing to pay. So he paid a lot of money extra to just to get the boat light as light as possible. I remember only one time when they said no. And that was when somebody came up with the idea, that was not to save weight, but that, is there any material heavier than lead so we could have the bulb smaller and reduce drag? So we looked into this. Yeah, we find a metal called Mallory. It's used in the space shuttles for radiation, and it's used in small areas for whatever balance system things. And then we did, it was a 47% heavier than lead, so the bulb became smaller. We did performance study, we presented it to the client and said, that looks good, what's the price? It said $6 million. The client said, PJ, I think that's money. But he was a very good client. And the boat came out exactly the way it is explained. There's no doubt about it. Done over 30 knots. Yeah, an amazing boat. Then another boat is 141 foot that we did for Scandinavian flying. That's a cruising boat. High-tech again with stops and all kind of things, but not built extremely wide. Very nice, with very nice interior details, which is designed by John Mumford, known for classic interior. And then in 2005 we did another canting field boat, which was actually based on our standard 56, but with canting, and this is the polar diagram for that particular boat. Also space, speed numbers, I don't have time probably go through that. This is the boat the way it looked. It didn't look like our standard 56, it was custom made deck, it's custom styling, interior was very modern. Using less wood and a lot of painted surface. Then, 2006, we did the 152-footer Big Jim. And that was a nice cruising boat, but also high-tech. Very light for what it is, but very comfortable cruising, designed by Design Unlimited. Interior was designed by Design Unlimited, and naval architecture was useful for it. This is pictures of that particular boat. This is just to see that we still do some smaller boats. So this is a day sailor, 43 feet. Stephen had a forward cabin with a toilet and galley or whatever. I don't think anybody ever stayed on night on the boat, but it's a nice boat to take out sailing in a breeze. I can tell you that for the day. Very, very nice toy. Then in 2008, we did an additional building in the harbor of Pietarsaari, which gave us better facilities. 2009, we did a 45 feet boat for an American, so we still are now and then doing a little bit smaller boat, but not that many. 2010, we did a very successful boat that's been very successful in races in the Mediterranean. But also a full cruising boat with full interior, very high-tech produced, but very light, full, comfortable interior. Engine room. And then 2011, we did this 197-foot classic look, but behind the surface, ultra-modern. When we did the 147-footer I talked about earlier, then our material suppliers said that's the biggest one in the world right now in prepreg carbon. When we did this, they said the same thing. Now you've done again the biggest prepreg carbon in the world. We really don't care about that, because that's not a goal. But this boat is a very high-tech boat, but classic look and classic design. This is another extreme, which is a racing machine we did in 2012, 72 foot. That's completely empty, nothing in it, not even paint. Plate saving is the main issue in this particular case. A year ago, we delivered 170 foot Herman Fred design boat. Again, high tech, but cruising boat. with a very special interior designed for this particular climate. Again, using very, very modern materials. And then again, prove that we can do a smaller boat. 2013, we delivered this boat. Classic 47. Andre Hook design. Very nice boat. But with a lifting thing, pre-brake carbon, very, very light. And very fast. When we look through the years, what we've done through the years, these are the number of yachts that we produce. As you can see in the beginning, we did standard models, so the numbers were high. And then it looks like we actually declined in activity because here, even 1 year, we don't have a boat. But we actually have increased our turnover from year to year. It's just the fact that we cannot compete anymore with serial production yachts that are industrially produced. So we have to move into bigger boats and custom boats. And this is where we are at the moment. On the construction, we have 175 footer, we have 160 footer, we have 115, and we have a 108 footer that we're producing at the moment at the yard. And we're doing a lot before the life cycle service for Norita 105, which is actually the first volley. So it's let's show you a fast presentation through those boats. That's the 175. That's the 116, and that's 115. And then one which is delivered next summer is a very, very fast modern 108. And this is Norita, which is the first volley. And this is in one way a good project for us, because Norita in its time, when it was called Volleygator, was a very, very modern boat. So we're pleased that we can do service on this boat, life cycle service. Whatever you do in business, and boat business especially, you can talk about fancy programs and software and whatever, but you need people. And I'm happy to say that I have had the fortune to work with what I consider to be the best boat builders in the world for 40 years. We have really good people. But I also had the fortune to work together with some of the best designers in the world. It's made my life very interesting. But most of all, the clients we have, you can't even see. They're amazing people, unbelievable people, individual people, successful. So I have been in a fortunate situation. And what I have, in one way, when you look at things in 40 years, they've gone so fast that I have problems accepting that it's 40 years. When I look at the boats we did in the beginning, I look at the boat today, sure, there's a big difference, no doubt about it, but not 40 years. When I look at the world today and the world when we started, when we started, I wanted to talk to a chief designer in Canada. I had to book a telephone call and I had to wait for 45 minutes to 60 minutes to get the call through. Today, I can talk to whoever I want, wherever in the world, whenever I want to do it. It's a question of seconds. I can send information packages, huge information packages to the other side of the world. But still, I don't accept that this 4 years. It's gone so fast that I have problems doing it. However, when I look at this young, handsome man, I look at that picture, and I compare it to what I see in the mirror in the morning. Believe me, it's 40 years. Thank you for listening.